Hi scholars, as you all know, we have just 2 days to go for the JAMB 2026 examination. So I've come up with 15 questions that cut across the 10 most repeated topics where questions usually come out from. So please do well to watch it to the end, and I wish you success in the examination. All right, thank you. Question 1 says, as you can see on the screen, what type of reaction is represented by the equation below? So here's the equation. Option A says fission, B says chain, C says ionization, and then D says fusion. So from what we have here, the right answer here is known to be fusion. So what do we call nuclear fusion? Nuclear fusion actually occurs when we have two light nuclei coming together to form a large nucleus. So like we have here now, we have these two light nuclei coming together to form a large nucleus. And on the other hand, we have what we call nuclear fission. Nuclear fission actually occurs when you have a larger nucleus being splitted into two light nuclei. So the right answer here is known to be fusion, and that is option D. All right, question 2. It says the electrochemical equivalent of a substance. So we have Z, which represents the electrochemical equivalent. We have it to be 0.00112 gram per coulombs. What current, that is I, what current we deposit 2.24 grams. So that's the mass, which is 2.24 grams of the substance in 10 minutes. So the time here is 10 minutes. So from the parameters we have here, we have Z in gram per coulombs. So the mass is meant to be in kilogram, but because the constant value that we have here, which is the electrochemical equivalent, is in gram, so we have to leave this in gram. You don't need to change it to kilogram. Let's say we have this now to be in kilogram per coulombs, and then we have our mass given here to be in gram. What do? We have to change this gram to kilogram, because the constant value given to us already has its unit to be kilogram per coulombs, but here we have it to be gram per coulomb. Please take note. So in this case now, leave the mass in gram. You do not need to change it to kilogram. And the time here needs to be changed to seconds. And 10 60, that gives us 600 seconds. So what is the formula that connects electrochemical equivalent, the current, the mass, and then the time? The formula is M equals to ZIT. So M, which is the mass, equals to ZIT, and we're looking for I. So what do? Make I the subject of the formula. So to do that, divide both sides by ZT. So this cancel this, and we have I to be M over ZT. So what is the value for mass? The mass there is known to be 2.24. 2.24 divided by, electrochemical equivalent is 0.00112 multiplied by, and time is 600. So please, you need to take note of this. In JAMB, whenever you have something like this, you don't need to waste your time. For most students, what they do, they will get the value for the numerator, they will get the value for the denominator, then they will not divide. By doing so, you are wasting your time. In order for you not to waste your time, just do it this way. That will give us 2.24 divided by 0.00112, then divided by 600. Again, 2.24 divided by this value, then divided by 600. Let's say we have A times B over C times D times E. In JAMB, you don't have to say, oh, let me get the value for the numerator, saying equals to AB, then over CDE, then you now divide. If you do that, you are going to be correct, but then you are wasting your time. In order for you to get things easily done, just say A multiplied by B, divided by C, divided by D, then divided by E. Do not say divided by C, multiplied by D, multiplied by E. Divide by C, divide by D, then divide by E, so you get your answer. So let's get this done. So 2.24 divided by this, divided by 600. So the answer will give us 3.3 0.33. And what is the unit of current? It is ampere. So the right answer there is option A, which is 3.33 ampere. I believe you are getting it. Okay. So the next one, this is a question under radioactivity. It says, in 180 minutes, the activity of a certain radioactive substance. So we are not giving the name of the radioactive substance now. We are not giving the name, we are not giving the value for the radioactive substance. But we are being told that the radioactive substance falls to 1/8 of its original value. Do we know the value for the original value? No. So we can just represent it to be, let's say, A. A represents the original value of the substance. So now, we are told that it falls to 1/8. So we have to do this now to have 1/8. So for half-life, what is half-life? Half-life is the time taken for a radioactive substance to decay to half of its value. So now, we have A here. Half of A will give us A/2. So we do not know the time taken for this substance now to get to its half. But we are being told that this falls down to 1/8. That is, we need to have A/8. If A/2 now undergoes half-life, we are going to have A/4. That is half of A/2. If I have A/2 now, divide by 2. That gives us A/2 multiplied by what? 1/2. So A times 1, that's A/4. So half of this is A/4. Then the next one will give us A/8. So which is 1/8 of the original value. So when we have 1/8 of the original value, we are being told that it takes 180 minutes. So the time here is 180 minutes. So question says that what is the half-life? We have to calculate its half-life. So for us to easily get the half-life, we need to take note of this. When we have 1/8, the time here is 180 minutes. So what will now be the half-life? That is for this A now to get to A/2. To do this now, having known that this is 180, then check for the total half-life that we have. How many do we have here? We have 1, 2, 3. We have 3 half-lives. So this will now give us 180 divided by 3. And that gives us 60 minutes. So here is 60. So for A to give us A/2, it takes 60 minutes. So for A2 now to give us A/4, we are going to add 60 to that 60. That will give us 120. And for us to have 180, add 60, that gives us 180 minutes. So let me use this certain question to explain what you need to know about half-life. So the question says that a certain radioactive substance, so let's say the value is A, has its half-life to be 2 minutes. So for this to get half, we are going to have A/2, and the half-life there is 2 minutes. And the question says that what will be the value of the substance left after 6 minutes? What will be the value of the substance left after 6 minutes? How do we do that? If I get this halved, this will give us A/4. And if I add 2 to this, that will give us 4 minutes. So if this also gets halved, we are going to have A/8. And if I add 2 to this 4, that gives us 6 minutes. So now the value of the substance left after 6 minutes, it is 1/8 or A/8. Do you understand? The original value is A. After 6 minutes, we have A/8. And you can also be told to find this now. You can be told to find the value of the substance that has gotten decayed. There's a difference between you being told to find the value of the substance left and then you being told to find the value of the substance that has gotten decayed or that has gotten disintegrated. So for us to get the value of the substance that has gotten decayed, that would give us A minus A/8. That is the original value minus what we have left. So if I have A now minus A over 8, so the answer here is going to give us 7A over 8. So this is the value of the substance that has gotten disintegrated. But if we are told to find the value of the substance that we have left, that is A over 8. I believe you are clear with that. All right. So the next question, it says, an object of mass 2 kg. The mass of the object is known to be 2 kg with a velocity of 10 meter per second. So the velocity V is 10 meter per second. Round a circle of radius 4 meters. So the radius is 4 meters. Question says, calculate the centripetal force on the object. So we want to get the value for F, which is the centripetal force. So what is the formula that connects M, V, R, and F? Centripetal force F is equals to mv squared over R. So what's the value for the M? That is 2. The value for the velocity is 10. So I'm going to have 10 squared, then divided by, what is the radius? 4. So 2 here 1, 2 here is what? It is 2. And we have 10 squared, that will give us 100 divided by 2, and the right answer there is 50 Newton. So which is option B. So the answer there is 50 Newton. So in case you are told to find the centripetal acceleration, here is what we call centripetal force. In case the question says calculate the centripetal acceleration, that has its value to be V squared over R. So we are now looking for the centripetal force. From our knowledge on force, force is equals to mass times acceleration. And we have mass multiplied by, the acceleration is V squared over R. So that is how we got centripetal force to be mv squared over R. So let me quickly say this now. You need to know the connection between the linear velocity and what we call angular velocity. So this is the linear velocity, and here's what we call angular velocity, which is the omega. So what connects these two together is V equals to omega R. So please take note that this is the tangential velocity or the linear velocity, and here's what we call the angular velocity, and this is the radius. So this is the formula that binds the V and the omega velocity together. All right. So the next question says, when a metal is heated to a high temperature, electrons are emitted from its surface. This process is known as dash. So the right answer there is thermionic emission. So what do we call thermionic emission? Thermionic emission is known to be the ejection or the release of electrons from the surface of a metal when it is applied to the surface of that metal. So you also need to know what we call the photoelectric emission. Some will call it the photoelectric effect. So it is known to be the release or the ejection of electrons from the surface of a metal when light of a certain frequency is illuminated on the surface of the metal. So when it has to do with light, we call it the photoelectric emission, but when it has to do with heat, we call it the thermionic emission. So for this, the right answer there is option A. The next question says, the shortest length of the air column in the resonance tube closed at one end, which resonates to a frequency of 720 Hz. So we have the frequency to be 720 Hz. Is found to be 30 centimeter. That is the length. So L is 30 centimeter. What is the wavelength of this sound in air? We want to get to know the wavelength of the sound in air. So for resonance tube, you need to know that the shortest length, which represents that of the first harmonic, that is the fundamental frequency now, the shortest length N has its value to be lambda over 4. Please take note of this. When it has to do with open pipe or the string, the N is going to give us lambda over 2. That's for the first harmonic. But in this case now we are dealing with the resonance tube. So you can try to relate the resonance tube and the closed pipe together. So the shortest length is L equals to lambda over 4. And in this question we are told to find the wavelength. So from here now, if you check the option, we have all options there in centimeter. So we don't need to change this to meter. So having known that L equals to lambda over 4, and then we want to get the wavelength. So wavelength is going to give us 4L. Then we are going to have this to be 4 multiplied by what is the length? 30 centimeters. And that gives us 120 centimeters. So we do not need the frequency. So the right answer there is 120 centimeters, and that is option B. Alright. So the next question says the resistances of platinum wire at the ice and steam points are 0.75 ohms and 1.05 ohms. So this is a question under the temperature scale. So for this now, we are comparing that of the Celsius scale. So which has its ice point to be 0 degrees Celsius and the steam point to be 100 degrees Celsius. We also call this the lower fixed point, and then here the upper fixed point. So comparing this now to that of the resistance. So we are being told that the value happens to be 0.75 ohms at the ice point. Here is 0.75 ohms. And then for the higher fixed point, we have it to be 1.05 ohms. So question says that determine the temperature at which the resistance of the wire is 0.90 ohms. So when you have this now to be 0.90 ohms, what will be the value at the Celsius scale? So to do this now, you need to be very, very careful. You are going to do it this way: x minus 0. X minus 0 divided by 100 minus 0. 100 here minus 0 then equals to 0.90 minus this. 0.90 minus 0.75 then divided by 1.05 minus 0.75. 1.05 minus 0.75. So this will give us x minus 100 then equals to 0.90 minus 0.75. That will give us 0.15 then minus 1.05 minus 0.75. Here will give us 0.3. So if we do well to cross multiply, we are going to have x times 0.3, which is 0.3x, then equals to 100 times 0.15. 100 multiplied by 0.15. So divide both sides by 0.3 here. Here is 0.3. So 0.3 cancels 0.3. So x now equals to 100 times this divided by 0.3. And the answer there is going to give us 50. So 50 what? 50 degrees Celsius. That's 50 degrees Celsius. I hope you understand. Alright. So the next question says, musical instruments playing the same notes can be distinguished from one another owing to the differences in their dash. So the right answer here is known to be quality. The right answer there is quality. And also, let me say this now pertaining to sound waves, that when you have a deep voice is going to have low frequency and what we call the low pitch. So for a deep voice, you are going to have low frequency and what? And low pitch. So that means frequency and pitch, they are directly proportional. And when you have a street voice now, for a street voice, it's going to give us high frequency and what? High pitch. Please do well to take note of this. Alright. The next question, as you can see on the screen, says sound waves travel through a medium by causing the particles of the medium to vibrate. The direction of vibration of the particles is dash. For sound waves, they are known to be mechanical waves. Mechanical waves are the kind of waves that require material medium, but the waves that do not require material medium, they are known to be electromagnetic wave. Example, we have the radio wave, the infrared, the visible. All of these are known to be electromagnetic waves. They do not require material medium. The one that require material medium, they are known to be mechanical waves. An example is the sound wave. So now, we can also categorize wave into longitudinal waves and what we call the transverse wave. So you can have sound wave now to be mechanical and then still known to be longitudinal. So you need to know that sound wave is a mechanical wave because it requires a material medium. It is also known to be longitudinal. Why? So for transverse wave, the direction of the wave is perpendicular to that of the particles, whereas that of the longitudinal, it is known to be parallel. So from what we have here, option D is the correct answer. It is parallel to the direction of the propagation of the wave. So that is the characteristic of longitudinal wave. So you need to know that sound wave is a longitudinal wave. Also, it is a mechanical wave because it requires a material medium. All right. The next question then, it says, a wheel and axle is used to raise a load of 500 Newton. So the load is 500 Newton by the application of an effort E, which is 250 Newton. If the radius of the wheel and the axle, so we have this big R to be the radius of the wheel, and we have it to be 0.4 centimeter, and that of the axle now is known to be 0.1 centimeter. Question says calculate the efficiency. So we want to get the efficiency. So this is a question under simple machine. So I did a video where I talked about 20 questions on the topic simple machine. Please do well to check the video out. All right. So from what we have here, we have the load, we have the effort, we have the radii given to us. This for the wheel, this for the axle, and we want to get the efficiency. So we need to know that from the load and the effort, we are going to have what we call mechanical advantage. And mechanical advantage is known to be load over effort. So in this case now, we have the load to be 500 Newton and then effort to be 250 Newton. And 500 divided by 250, this will give us 2. So mechanical advantage has no units. Because if I decide to put the Newton here, let's say I have Newton here, then I put the Newton here now. So Newton will cancel out Newton. So mechanical advantage, it has no units. So now we have the big R and then the small r. And for the wheel and axle, you need to get the velocity ratio. And what do we do in getting velocity ratio? Velocity ratio for the wheel and axle, it is known to be big R over small r. And the big R there is 0.4. And while that of the axle is known to be 0.1. So if you divide this now, we are going to have 4. Also taking that velocity ratio has no units. Velocity ratio has no units. The mechanical advantage also has its name to be the force ratio. So we call the mechanical advantage force ratio. So efficiency is said to be mechanical advantage over velocity ratio multiplied by 100%. What is the MA? We have the MA to be 2 over velocity ratio there is 4. Multiplied by 100%. So 2 here 1, 2 here is 2. 2 will go in 100, that's 15, and then we have the right answer there to be 50%. So the efficiency of this machine is 50%, and that is option A. So like I said earlier, please do well to check the video you can see on the screen to learn more about simple machine, because surely you've seen questions, at least 2 questions on simple machine. All right. So the next question says the total power drawn from the cell in the circuit above. So this is the circuit, it's dash. So we have this circuit now containing resistors. So we have this resistor 4 ohms in series, and then we have these 2 4 resistors connected in parallel. So we need to get the total effective resistance. So we have this in series now, and then we have this in parallel. But we have to get the total effective resistance. So what we need to do now here is that for this now, for these 2 resistors connected in parallel, let's get the effective resistance here. So, and whenever you want to get the effective resistance of resistors connected in parallel, this is what I have to do. You are going to have 1 over R, giving us 1 over 4 plus 1 over 4. Please, when you have capacitors connected in parallel, and then you want to get the effective capacitance for capacitors connected in parallel, you are not going to have it to be 1 over, you are going to have it to be C1 plus C2 plus C3. Just add them up that way. So it's opposite. In case you want to know more about capacitors, I did a video where I talked about 15 to 20 questions on capacitors. Please check the video, you can see right on the screen, and do well to study. All right. So now this will give us 1 over R equals to, since we have the same denominator, just add up the numerator. That's 1 plus 1, which is 2 over 4. We are not looking for 1 over R. We want to get the value for R. So get the value for R. You are going to find the inverse, which is 4 over 2. And 4 divided by 2, that will give us 2 ohms. So the effective resistance for this is 2 ohms. So these 2 ohms will now be in series together with the 4 ohms. So this is what I mean. We have the 4 ohms this way. So this is the 4 ohms, and here is the 2 ohms. Now in series. So for us to get the effective resistance for these 2 resistors, now in parallel, we are going to add them up. So this will now give us, for us to get the effective resistance, we are now going to have the 4 plus 2, and that will give us 6 ohms. If you want to get the effective resistance for resistors in parallel, it has to be 1 over. But if you want to get the effective resistance in series, you are going to add it up this way, 4 plus 2. So the opposite goes for capacitors. All right, so now that we've gotten the effective resistance for this circuit, we have the voltage to be 12 volts. V is 12 volts, and we want to get the power. So the first there is P equals to IV. We have P equals to V squared over R. Then we have P to be I squared R. These are the 3 formulas you need to take note of pertaining to power. So P equals to IV, P equals to V squared over R, P equals to I squared R. And you need to know that from Ohm's law, that we have V to be equals to IR. That V is equals to IR. You can also be told to find the energy. You know that power equals to energy over time. So if I want to get energy, energy will give us power multiplied by time. So if power is IV in this case, energy will give us power times time. That will be IVT. Because energy is PT and the P is IV. So just put T here. Here will give us V squared over RT. Here will give us I squared RT in case of energy. But we are told to find the power, and we have the value for the resistance and the value for the voltage. So the right formula I can use here is the second one, which is P equals to V squared over R. So I'm going to have P to be V squared over R. So what is the value for the voltage? That is 12. I'm going to have 12 times 12 divided by the resistance there is 6. 6 here 1, 6 here is going to give us 2. And 2 multiplied by 12, that will give us 24. And you need to know that the unit of power, it is watt. So the answer there is 24 watt, which is option B. So the next one says a galvanometer of internal resistance 100 ohms. So we have the resistance to be 100 ohms. Gives a full scale of deflection for a current 10 milliampere. That is the current of the galvanometer, which is 10 milliampere. We know by now that galvanometer is used to measure small amount of current. We also call it milliammeter. So it measures small amount of current. So that is why we are having the value to be milliampere. And in this case, I need to change milliampere to ampere, which is divided by 1000. We are going to have it to be 0.01 ampere. Calculate the value of the resistance necessary to convert the galvanometer to a voltmeter reading up to 5 volts. So V is 5 volts. And we are told to find the resistance necessary. So that will give us the resistance of the multiplier. If you want to change galvanometer, or you want to convert galvanometer to ammeter, we make use of a low resistance shunt. We make use of a resistor now, and this resistor has low resistance, and we call it the shunt. So the shunt helps to convert galvanometer to ammeter, and this shunt needs to be connected in parallel with the galvanometer. But if you want to convert galvanometer to voltmeter, we make use of a low resistance resistor. We call it the multiplier. The multiplier helps to convert the galvanometer to voltmeter, and this multiplier is always connected in series together with the galvanometer. So in this case now, we are changing galvanometer to voltmeter from the question. So we are making use of the multiplier. So the question says that calculate the value of the resistance necessary to the resistance of the multiplier. So the formula says V over I minus RG. So what is the value for V? That is 5. And that of the current is 0.01 minus that of the galvanometer is 100. So 5 divided by 0.01, that will give us 500. Then minus 100, we are going to have this to be 400. So 400 what? 400 ohms. So the answer there is option D, which is 400 ohms. But when it has to do with the shunt, we have RS to be RG over I minus IG. So this IG represents the current of the galvanometer. Here it represents the resistance of the galvanometer, and here's the main current, and IG still represents the current of the galvanometer. So this is for the shunt, and here is for the multiplier. All right. So the next question says, an engineer intends to deviate a light ray from its path by 120 degrees. So the value there represents the angle of deviation, which is 120 degrees. From a plane mirror, calculate the angle of incidence. So we want to get the angle of incidence. So take note of this, that angle of deviation is known to be 180 degrees minus 2i. Angle of deviation is equals to 180 degrees minus 2i. So what is D? D there is 120 degrees equals to 180 degrees minus 2i. So I have 120 degrees here. If this comes here, that's minus 180 degrees, then equals to minus 2i. And 120 minus 180, that will give us minus 60 degrees equals to minus 2i. So divide both sides by minus 2. So minus cancel minus, and 60 divided by 2, that will give us 30 degrees. So the angle of incidence there is 30 degrees, and that's option D. And the very last question says, the light of velocity 3 times 10 raised to power 8 meters per second is incident on a material of refractive index N. So from the value we have here, the 3 times 10 raised to power 8 meters per second represents the speed of light in air. So speed of light in air, that is 3 times 10 raised to power 8 meters per second. And we are being told that the refractive index is N. If the velocity of light is reduced to 2.4 times 10 raised to power 8 meters per second in the material, so we have the speed of light in that material now. We do not know if the material is in glass, but the value for the speed there or the velocity is 2.4 times 10 raised to power 8 meters per second. Question says that what is N? So we want to get the refractive index of that material. We want to get the refractive index of the material. Take note of this. Under refraction, when you have light traveling from one medium to another medium, there's going to be changes in the speed of light. When you have light traveling from a medium to another medium, there's going to be a change in the speed as well as the wavelength. If you have light traveling from, let's say, air to glass, the speed is going to be different as well as the wavelength, but they are going to possess same frequency. Let me repeat myself again. When you have light traveling from one medium to another, let's say it is moving from a less dense medium to a dense medium, or from a dense medium to a less dense medium, there's going to be changes in the speed of the light as well as the wavelength, but they are going to possess same frequency. Let's say we have the refractive index of glass, and we have the light moving from air to glass. I will have the air here. So now, if we want to relate the value for the speed or the velocity, I'm going to have this to be speed of light in air over speed of light in glass. And that one, let's say we have the refractive index of water, and then we have this to the glass. That is from glass to water. This is going to give us the speed of light in glass over that of the water. The same thing is applicable to that of the wavelength. So this now I can have the wavelength of light in air over that of what? That of the glass. So now in this question, we are given the refractive index of the material. The refractive index of the material. And we have air, so that means it is from air to the material. So this will give us the velocity of light in air over velocity of light in that material, and not otherwise. And we have this VA to be 3 times 10 raised to power 8 divided by that of the material is known to be 2.4 times 10 raised to power 8. So divide 3 now by 2.4. So that will give us 1.25. And you know that 10 raised to power 8 will cancel 10 raised to power 8, so this will give us the answer. So the right answer there is 1.25, and that is option C. So that is the right answer. So we've come to the end of the division class, and I believe you all have enjoyed the class. Please kindly do well to subscribe, to like, and then to share. See you in our next class. Bye.